All right, now that we know everything about the system, what it does, its job, it's what it's supposed to do, all the problems, let's see how it looks actually in a quick sketch. And there's another important part that it's gonna be introduced here. So there's a quick sketch, one example of having a run. Usually the 4-inch pipes, they come in a 5-foot section, that's standard, so that's why I put the 5 sections. So let's say that we have 25 feet long straight duct, so it's coming from the dryer in and through the exterior vent. And we also have another system that has an obstacle somewhere inside the wall. Again, we don't know what it is, we don't know where it is, but it's there. So it's got to go around certain obstacle. This, you will hardly ever see a duct that will go. Well, it happens, but very rarely you'll see the straight run. That's the ideal case. More or less, it's the elbows and turns and the resistance in the system. So 25 feet of a straight run. If we look at the house, so we come to the laundry, you will see that where the wall is. So this is where the flex hose is going in, and you know that it's there is a connection there going into the wall. That's all you see. And then you go outside. You know where the vents are. So you measure the distance between outside and this wall. So it is the physical distance between, but not the length of the ductwork. Then you got the actual distance. So this is when you actually do find out by whatever means. So you get to see the actual duct, so you know exactly what it's doing and where it's going. So the actual length here is, we know that it's got 10, 20, 25. It's got these two sections here short, each is 2.5 feet, so 1.5. So this run here, it's got the actual length of 30 feet. So 5 foot longer than this one. You know, it doesn't seem like much, 5 foot, it's just not a big deal. Well, actually it is a big deal, and now we'll come to the equivalent length. The equivalent length is the effective length that's measured by using the straight, least resistant sections of the duct. So each element is translated into the straight, solid run. Okay, so the average dryer is capable of pushing the air through the exhaust system. That's about 25 to 30 feet long without any restrictions, without any penalties on its performance. And again, and this is the duct that's got no obstructions. It's a clean duct, 30 feet long. Again, 30 feet of equivalent length. What does that mean? So you have to take into consideration all the additional resistance that will be created inside the system. And one of the greatest contributors to it is that short radius sectional elbow that we saw earlier. So that little elbow creates as much friction as the 5 foot straight duct. So that means that this little elbow is worth 5 foot of a straight run. Unlike that, the long radius elbow actually creates as much resistance as 1.5 feet. So that's a huge difference. Okay, so let's see what that means in this particular case. So 5 feet. So we said that this thing's got the actual length of 30 feet. But, so we have a sectional elbow that creates friction as much as 5 feet of a straight duct. So we got 4 of these elbows. So 4 times 5, so it's 20. So just the elbows, they create the same friction as 20 feet of a straight run. So you got 30 feet of actual plus 20. So this actual run is got an equivalent length of 50 feet. obviously this is way beyond, it should be beyond the capabilities of every average dryer. So now we're facing a problem in terms of drying our clothes. So again, the outcome is a longer drying time and all sorts of problems. And repeat, this is in case there's nothing in the system, so there's no additional resistance in the shape of accumulated lint or anything like that. Like again, given this is working perfectly. Doesn't look like that. It's a straight run if it's a flex. So there's a lot of conditions, a lot of things have to actually match to get the system to work properly as a whole. So how do we reduce the equivalent length? Well, the only way to do it, there's nothing we can do about the sections, the straight sections, because obviously you got to reach from A to B. But what you can do is you can replace these restrictive fittings with the long radius. So if we do that, let's say that we take these 4 elbows out and instead we replace them with the long radius elbows. That still remains the same. The distance, the length of the actual length of the ductwork hasn't changed at all. We got 30 feet plus. Now we calculate, so 1.5, so that means 3 and 3 is 6. So we got 30 plus 6, so we got 36 now feet of equivalent length. That's quite a change from 50. So it's a huge improvement. So this is one and basically the only way you want to improve the efficiency of the system is changing the fittings, unless you want to redo and complete run and do new run, find a new pathway, new vent and all that. Again, this is all given. This is fine. There's no restrictions here and no restrictions on the side, on the exterior wall side where the vents are. This is the reason why I said in the beginning that there's very, very few systems out there that actually run efficiently and the way at the maximum peak performance, because there's so many things that could go wrong, and some of these things usually do go wrong. Our job is to approach every single one of these elements and make it as efficient as possible. So when you sum it up, you can see that it's all about the airflow. All these, the resistance and all the elements that create, so it's all about resistance. So it means that basically it's what defines, it's the aerodynamics. It's what governs the flow through the system. The 3 main points is to make it as short as possible. So that means if you have the dryer, and obviously if you got a wall that's closer, you're gonna run it through the closer to the wall, or you're gonna move your laundry room and place the laundry room somewhere else, like somewhere closer to the exit. So you'll have like maybe 5 feet of total run instead of 30 or 50. The second point is make it as straight as possible. Again, not always possible, but if there is a possibility, even if it's a longer run, get the longer run, make it straight. It's gonna have a shorter equivalent length than maybe a shorter run with a lot of fittings on. And the third point is, if you're already stuck with whatever you have, change individual fittings to make it, well, the fitting, not just the fitting. Change this, change the vent, change this hose, change every single element that you can, and replace it with more efficient one. Okay, this brings us to, this would be the last section. It's basically a summary of everything that was said here. I'm just gonna kind of look into what we do in terms of a field assessment. So when you come to the house, visual is the first step. So measuring the distance, the physical distance between the actual dryer and the wall, and then obviously looking at that concealed duct behind the walls. And the only way to find out the actual run, see how this duct works, how does it go inside, and to see its condition inside, that's by using a video camera. You either insert it through the side where the dryer is, and from the outside, and that way you scope the system, and you have a really pretty good picture of what the system is like, what the damage is, what condition is, and eventually what needs to be done to fix it. Without a video inspection, there's very little you can do unless you're gonna tear down the drywall and expose all the ductwork there is. So in terms of repairs, there's two ways. If you're gonna reuse the existing system, just replace all the fittings. If there's any elements in the wall, any fittings that could be replaced, replace it with the more efficient ones. If there are any runs that are crushed or damaged, replace whatever you can. Obviously, this is the difficult part, is to do any repairs on the ductwork. You need to cut into the walls. Most of the time it's a drywall, but whatever material is, as the duct is behind, you have to access it, and so that means that there is some cutting involved. On top of cutting into drywall, you come to see that there's also other elements in there. So there's electrical, there's plumbing, there's a lot of framing. So most of the time, repairs are quite difficult, especially if you want to kind of to try to change and move the run to make it more efficient. Sometimes it's just completely abandoning the existing run and run it to the other side, or like I said, moving the dryer to a different location, which again it requires other things that needs to be done, plumbing and drains, and there's a lot of other stuff, electrical and so forth. There's always a way to make it work, and that's what we do. That's what we always try to do. Try to get it done in the most efficient way, but also without breaking a bank. Let's just go over it again. So obviously the drying time is the first, and that's the most noticeable. This is what the people using dryer that will notice the first. The reduction in the drying time after the repairs are done. So obviously, drying time, so you don't have to go and restart the dryer 2 or 3 times just in order to get your clothes dry. So that's the most frustrating one, but it also brings like the lengthier running time, obviously more energy, so it costs more. Then, as you saw some of these vents, when they plugged solid, that means that the air that's being expelled out of the dryer is not venting through the vent out. So that air, it's not moving from the dryer. It does leave, some air does leave the dryer, not nearly as much as it should. That's why the clothes remains wet for a longer time. But that also means that air that does move the dryer, it finds its way out somewhere else. If not through the vent, it will find its way through the gaps, cracks, and anywhere in the system where there's a weak link, it will come out. And we know what that means. So that lint, again, it's not the air itself, it's the lint. If it gets indoors, people notice that too. If you wipe your dust, and every couple of days or even more often, you see a white layer of fine dust on your furniture, well, especially on a dark furniture. You know that you have a problem, and that lint is finding a way into your living space. And now you add a sensitive person to it, can get to a serious sneezing and coughing. Another one, and also a big one. So that air, if it's not leaving the enclosure, it's staying in. And that air, as we know, is very moist. It contains a large amount of moisture in it, and if it's not going out, it's going into the cavities. And most of the building materials are very, very sensitive to the water. It's actually, water is the worst enemy of pretty much all the building materials. That can bring, in the extreme cases, we talk about rot and growing stuff, mushrooms and other stuff inside inside the wall cavities, and we all know how that affects health. On top of that, there is also another factor. With the very efficient system, the need for cleaning will reduce quite a bit. Periods between cleaning will be very, very long, and that's also a major saving. So instead of having to clean it once a year, you'll do it once every 3 years or so. So that's also another saving that should be considered when choosing a repairs or a restoration of your system. With this, I think I can wrap up this video about the dry vent, residential dry vent. We'll be adding some more videos of high-rise residential dryer systems, and maybe even a case study of one particular house, the problems that we came across and the solutions. So there will be more videos coming from us, so stay tuned, and thanks very much for watching.